Hello there and welcome to Lower 6th Further Maths A-Level. This is the core part of the syllabus, Specimen Paper Question 7. So it's a big wordy one, this one, so we're going to have to read through this text and pick out the important bits of information. The population of the zebu cattle in a particular country is modelled by two subpopulations, the adults and the juveniles. In this model, the only factors affecting the population are the birth rate and the survival rate of the population. Data recorded in the preceding years 2018 was used to suggest the annual birth rates and survival rates. The table below shows this information. So 23% of the adult population effectively gives birth to a new juvenile cattle. 97% of the adult population survive. The juvenile population can't give birth because they're only juveniles, and 83% of them, 87% of them survive, 13% of them will unfortunately die. It is assumed that a third of the population of juvenile population become adult population in the next year. AN and JN are the respective subpopulations in millions of adults and juveniles n years after the 1st of January 2018. The population of the adult population in year n plus 1 satisfies the equation AN plus 0.97 AN, so that's the survival rate of the adults, so 97% of the previous year's adults survive, and we add that onto a third of the surviving juvenile population from the previous year, so 87% of them will survive, and then a third of them will become adults in the next year. So that's how this formula is created. And when you simplify this, you'll get 0.97 AN from the first bit, and then a third of 0.87 is 0.29. So what we have to do next is form a similar equation for the juvenile population in year n plus 1. So let's go ahead and do this. So part A will have Jn plus 1. So first of all, we'll have 87% of the juvenile population survive, but only 2/3 of those will remain juveniles. So we're going to have 2/3 of 0.87 of those juveniles. And then we have to add on the birth rate. So because 23% of the adult population then effectively give birth, we're going to have 0.23 times by, not Jn, by AN, the amount of adults in the previous year. So simplifying this, we're going to get, let's put the AN first, 0.23 AN plus 0.58 lots of the Jn. Okay, so that's how we'll work out the juvenile population. Okay, the total population on the 1st of January 2018 was estimated to two significant figures as 1.5 million zebu. Of this 1.5 million, 1.2 million are adults. So we can infer from that 0.3 million are those juveniles. Find the value of P in the matrix M such that the population of the zebu can be modelled by the following system. Okay, let's sort out the initial amount of zebu cattle. So it's 1.2 on the top. That probably refers to the 1.2 million adults. So in the bottom must refer to the initial juvenile cattle, which we worked out earlier was 0.3. So in this case here, P is equal to 0.3. And the M part of this matrix is formed by those two equations that we had on the previous slide. So let's go back and look at them. So it's 0.97 AN plus 0.29 JN, that's the first equation. And JN plus 1 equals 0.23 AN plus 0.58 JN. So going back to this point here, we'll have 0.97 AN, and this is going to form these coefficients that we're writing down here are going to create that matrix M. Okay, perfect. So these are our two system of equations. So all we need to do now is just put it into a slightly different form involving a matrix and a couple of vectors. So the matrix here is going to be 0.97, 0.29, and that will be multiplied by an and then by jn. So effectively what we've got here, you can see if we multiply these out, we'll get that first equation. The second equation will go on the bottom row, like that. Perfect. So the matrix M is equal to 0.97, 0.29, 0.23, 0.58. Perfect. Let's move on to the next bit, part C. Using this model, so let's just quickly write down that model again. So it's A0, J0, 1.2, 0.3. And the equations were an plus 1, jn plus 1 equals 0.97, 0.29, 0.23, 0.58. Lots of an and jn. Okay, sorry about that. Let's carry on. So the total zebra population in the 1st of January 2017. Right, okay, that's last year from the initial population. So we need effectively here n equals -1, and let's see what happens here. That will give us A0, J0 in this right-hand formula here, which will equal the matrix that we have. And then that will be times by, if n is -1, that would be A -1 and J -1. So what we need to do here, this A1 and J, A-1 and J-1, that is the population in the previous year. So to work this out, we'll need to inverse this matrix here. So to get this, we're going to need to do 0.97, 0.29, 0.23, 0.58, inversed, pre-multiplied by the inverse of A0, which was 1.2, and 0.3. And that will give us our A -1 and our J -1, which is effectively the amount of zebu in the 1st of January 2017. So get your calculator out, click the menu mode, option 4 for your matrices. You all know how to do this by now. 2 by 2 matrix, you need first of all type in the values for the different cells there. Click AC and then option and define a second matrix, a 2 by 1 matrix that's 1.2 and 0.3. Clear that, and then recalling your matrices using the option button again, you need mat A, and then you need to use the -1 power on your button on your calculator there, times matrix B. Press enter, and what do you get? You get 1.228 and 0.0302. So it looks like from that that we're going to have 1.228 million adults, and not many of these babies, just 0.03 million juveniles. So that's not many in comparison to the next year, that's 0.3 juveniles. So it looks like these juveniles are going to be continually growing. So we'll see that appear in part D. The predicted juvenile population of zebu in the 1st of January 2017. So that's going to require 7 lots of this iteration to go through. So what we need is A7 is going to be, and J7 can be calculated by, doing m to the power of 7 lots on the A0 and the J0. And this is what we're going to do here on the calculator. So continuing those buttons that we had before, unfortunately this is the only way of doing it. you need to do mate times together 7 times. The power button doesn't work here, I did try it. Times by your matrix B, and that will give you the adult and juvenile population in 2025, 7 years' time. So what we've got here is we've got 2.1173. So that's a lot more of these zebu cattle, about 1 million more than we did have before, and 0.9381, many more juveniles that we had before, million juveniles, and that's all it wanted, the prediction of the juvenile zebu population in 2025. So that's the answer to part C, II. Moving on to the next bit, state as a result of the predictions in your model, the country will export 15,000 juveniles to a neighbouring country at the end of each year. Adapt the model from 2018 onwards to include your exports. So what we'll have to have is AN plus 1, JN plus 1 equals the same matrix that we had before, 0.97, 0.29, 0.23, 0.58, lots of AN and JN, and if we're exporting 15,000 juveniles at the end of the year, then we're going to have to subtract 0, and 15,000 turned into 1 million, so you'll get 0.015. Just like that. Okay, so that's part D. Part E, state a limitation of this model. So in this model here, let's think back to our situation. This export may have consequences on the survival percentages or other factors. Okay, so anything you can think of there that links it back to the original question and as long as it makes sense according to the question, is absolutely fine there. So you have to really link it back to the context of the question. Alright, 13 marks.